Right now, the hardware running artificial intelligence is getting faster, software is becoming more efficient, and the price of generating a single word from a frontier AI model is in free fall. This chart shows a strange divergence. As the unit cost of AI drops, total enterprise spending is actually accelerating. Organizations are finding that as the technology becomes more useful, they end up consuming far more of it, driving their total budgets higher than ever. During the initial wave of AI, projects were treated like research experiments. Demos were funded to prove a model's capability. When the goal is simply to see if a system can answer a question once, the long-term cost of running that system stays in the background. But as AI moves into production, the challenge becomes operational. These systems have to work inside daily workflows and connect to live data. Success now depends on whether the business can afford to run that intelligence repeatedly and at scale. This brings us to inference, the specific moment a model takes a prompt and calculates a response for a user. This creates a stark financial divide. Training a model is a high-cost capital investment that happens once. Inference, however, is a perpetual operating expense that hits the budget every time a user interacts with the system. It is easy to view these costs through the lens of a single demo, where one question equals one cheap answer. In a production environment, that consumption is constant. When thousands of employees use these tools for every task, the budget scales with every word generated. This reality, where the cost of usage outweighs the cost of creation, is what defines the inference economy. The primary driver behind these rising costs is a shift towards agentic AI. In this architecture, a user provides an open-ended goal. That single input triggers a multi-step workflow. The agent breaks the goal into subtasks, querying internal databases for context. It calls external tools, evaluating results, and autonomously revising the plan if incomplete. Each of these internal steps is its own hidden inference event. A single prompt from a human can set off an extensive series of automated requests that the user never sees. Agentic AI turns a single response into a persistent chain of consumption. The more capable the agent, the more infrastructure it consumes to complete its work. These reasoning loops eventually hit the physical hardware of the data center. Every time an agent breaks down a task or retrieves a document, it taxes CPU logic and memory systems. The heavy lifting extends through the entire server, not just the specialized AI processors. There is significant friction at every layer, from the energy required for cooling to the security protocols that must verify every piece of data the agent touches. This creates a system-wide tax on the enterprise. The total cost of a response is the sum of the vast network traffic, the heavy storage access, and the physical power demands needed to sustain the workflow. Traditional technical metrics like cost per token only measure how the hardware performs. They don't reflect whether the business actually received a valuable result. A fast, low-cost model can become expensive if it requires constant human oversight or 5 different attempts to get an accurate answer. The industry is moving toward a more practical standard, cost per useful outcome. This measures the total expense of a resolved support ticket or a completed document review. By focusing on the cost of a finished task, leaders can see which AI workflows are actually profitable and which are just burning compute cycles. Operating in this environment requires a new playbook. It starts with auditing the baseline, understanding the time and cost of a human-driven process before the AI is even introduced. Next is workload design. As this funnel shows, simple tasks should be routed to smaller, highly efficient models. The most expensive, frontier models, should be strictly reserved for high-value reasoning that justifies the cost. This approach separates organizations running flashy experiments from those building sustainable, governed systems that can scale. Model performance is what allowed AI to enter the enterprise, but mastering the operational economics is